Okay, good evening. Can, can you hear me? I love that you comment to say something. So the last chat, can you hear me? You're following me. Just would love that you say something. Alright, but what about now? How about now? Give me a better now. Yeah, good evening. Good evening. Good evening. Okay, so yeah, I know it's a very odd hour in the night. Well, this is dedicated towards the people that are having exams this week. Today, okay. I think some people cannot hear me. Can you hear me? Can you hear me?
Okay, you should be able to hear me now. I think it was my earpod that was connected. Oh yeah, you should be able to hear me now. Okay, can you still hear me? The person that is saying I should increase my voice. Can you still hear me? Can you hear me now? That is chi. I don't know who that is. I don't know how to pronounce this, but it ends with agbo. Can you hear me now? Is it better? Is it better now? Good evening, everyone. All right, so I've always wanted to do a live session, but I've never really thought of it before. So I just said, okay, I'm a bit active tonight, and I just released a video on YouTube on what to do a night before. Oh, I need to screenshot this. We're at 31 on the call. What to do a night before your exam, and I know that sincerely a lot of people have several questions for me. Exactly 2 years, 3 years ago, April, I can't remember the right date, but I think it was May, around May 14th or something like that, 2022, when I wrote my UTME examination. And the night before my exam was a very memorable moment for me. And I'm very sure that some people are having their exams tomorrow. How many of you guys are having your exams tomorrow? If you're having your exams tomorrow, just say, I'm having my exams tomorrow. Today we're going to be answering several questions as it pertains to, the people who are having exams this week. And I'm just going to be taking your questions and giving you the tips and tricks that I was not able to explain in my videos in this live session. So how many of you guys are having exam? Just if you're having exam tomorrow, just let me know. Just type I'm having exam tomorrow. Or just if you just whatever your date is, just let me know that you're having exam at so day. Let's keep it coming. Let's keep it coming, guys. Okay, I'm having exams today. That is amazing. So I hope you have printed your slip. I hope you have done all the necessary things. Okay, so while you're still answering that, I want every one of you to gather your questions. I believe that there are some things that you have in your mind, and I came here with some tips and tricks that I've not been there are so many videos I want to make that I do not have time to make. So we're going to be talking about what to do when you see certain questions in chemistry, which is my area of specialty, what to do when you see certain questions in physics, what to do when you see certain questions in biology, in I'm not really I don't really know much about math, but in English as well. So we're going to be looking at some of these topics in this I wanted to say courses, and I remember that it's only me that does courses. But some of these topics in this subject, right? So yeah. So before we go into that, who has a question for me that you just want to ask me and you just love me to answer? Who has a question for me? I want to know if this live session is recorded. I don't know. It's my first time going live. Oh God, help me. Okay, who has a question for me? Just kindly drop your question while I, you know, share some things about. So tonight we're going to be starting with organic chemistry. I don't have a board. I don't have so many things with me right here, but tomorrow will be better. Tomorrow we'll be looking at. I'll try to fix something that would ensure that we have a teaching session, right? And where we can, teach some things and solve some questions that the people that are going to be having exams today will see. So, um, Ugo Chinyere is asking a question. Sir, questions like mirrors, what do we do? It is so bulky to read. Okay, the thing is, I can't answer that question at the moment. But like, who has a question about, the exam that they're writing tomorrow and what to do in terms of strategies and techniques to approach, certain questions, or in terms of strategies and techniques to prepare for your examinations. Those are the kind of questions that I would love us to ask today. For tomorrow, we'll look at more of your questions on um, the calculations and these other things that you have mentioned. So please throw your questions in. I would love to take them now. Please kindly throw your questions in. Okay, so in the meantime, let's quickly have a quick chat on organic chemistry. So who wants to try? What do you understand by organic chemistry? I'll just give you a few seconds. But while I'm still saying that, I would just love to tell you about carbon. So carbon is one of the main substances that or elements that we study when studying organic chemistry. And I would not define organic chem. I'm tempted to do that, but I would leave somebody in the comment section to do that. And carbon is in group 4. It's an element in group 4, and carbon can be divalent and it can be tetravalent. So what does it mean for carbon to be divalent? For carbon to be divalent, that means that it has all right, so it has two electrons out of the four electrons in the outermost shell. To How would I put this? It has two electrons that are free for bonding, right? So there's a principle to valency. There's a principle to valency. Carbon can present with an oxidation state of 2 and an oxidation state of 4. Valency and oxidation state, they are usually really very similar. So it is when carbon is in the oxidation state of 4 that it really works, or it's really that we talk about carbon in organic chemistry. In organic chemistry, the carbon has to be tetravalent. The carbon that is bonding with any other atom has to be tetravalent. That means that if you are looking at that carbon, there has to be at least four single bonds attached to it. So why do I keep saying tetravalent? Tetravalent. So carbon is what element in the periodic table? What number? I need somebody to say something. Okay, the chemistry of hydrogen and carbon compounds. Okay, you're not wrong. You're not wrong. You're not wrong. I'll refine your definition. Carbon is element number what on the periodic table? I want to let's have let's have somebody to answer that. Carbon is element number what on the periodic table? Let's see the answer now. It's very simple. All right. So since nobody's saying the answer, let me just say the answer. So carbon is element number 6 on the periodic table. Hydrogen, helium, lithium, beryllium, boron, carbon. So since it's number 6 on the periodic table, it will be a configuration will be 2, 4. KLMN shell, right? So we're going to revise. I'm going to try as much as possible until you guys are feeling sleepy and until I am feeling sleepy to revise some things and just to talk about some things, even though we don't have a board. But let's look at some possible things that can still come out in your exam tomorrow. So element number 6. So the valency, so the electronic configuration is 2 4. So we have 4 electrons in the outermost shell, right? So now, why can the valency be 2 and the valency be 4? This is very, very simple. Now, remember when we were writing the SPDF hybridization, SPDF electronic configuration? Who knows about the SPDF electronic configuration method? Who knows about it? 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 Let's keep the comments coming. Who knows about the SPDF electronic configuration method? Who knows about the SPDF electronic configuration method? Is Matthew on this call? Is Chinyeri on this call? Who knows about the SPDF? Just say it if you know about it. Just say I know about it. I just want to be sure if we know about it. Okay. Oh, you know about it. That's good. That's very good. So the SPDF electronic configuration method is what we are going to be using to prove that carbon can be both by tetravalent and divalent, right? So if we're writing carbon, which we have said the electronic configuration is 2 comma 4 because the atomic number is 6. And what is atomic number? Atomic number is the number of protons. Let me tell you one thing that they can ask in your exam tomorrow that they can use to confuse you. They can say, which of the following is the correct definition for atomic number? Atomic number, you can put option A is the number of electrons in an atom. Option B is the number of protons in an atom. Option C is the number of neutrons in an atom. Option D is whatever option D is. So which one do you think is the correct answer for atomic number? Can somebody try? Try. Option A, the number of electrons in an atom. The number of option B, the number of protons. Option C, the number of neutrons. I'm just giving you 3 options. Which one of them do you think is the atomic number of would you say is the atomic number of an atom? Let's keep it coming. Okay, what is option B? Option B says the number of protons, yes, in an atom. So that's very correct. So atomic number is not the number of electrons in an atom because when you say it is the number of electrons, sometimes an atom might have lost or might have gained electrons, so we can't judge by that. But the proton number always remains the same, so that's why we say it's the number of protons in an atom. So now, writing the electronic configuration of carbon in the SPDF configuration, we have 1s2. Remember, they fill each orbital singly before pairing up in a degenerate orbital. Which rule is that? That is Hund's rule. That is Hund's rule of filling orbitals. So we fill in 1s2. So 1s2 is the subshell. I have a video on this. We are treating organic chemistry, but I'm just trying to explain some inorganic things that you have to understand in organic chemistry. So 1s2, then we go to 2s2, then we go to what? 2p2. So 2p2, on a normal day, the p orbital, the p subshell has how many orbitals? How many orbitals does the p subshell have? Let me count. Let me give you options. Option A, 1 orbital. Option B, 2 orbitals. Option C, 3 orbitals. Option D, 4 orbitals. How many orbitals does the p subshell have? How many orbitals does the p subshell have? I want to see smart kids here. How many orbitals does the p subshell have? I really hope this live session is recording, Sha. I want to try something. Let me know if you can hear me. Okay, could you hear me that time when I was talking? Could you hear me that time when I was talking? Okay, so that was the volume, that was the microphone. Okay, so if you're asking that what of what of the answer you don't know, the answer you don't know. Okay, so let me explain. So I was saying that it is, yeah, the p orbital has, the p subshell has three orbitals. And what are the names of the three orbitals? 2px, 2py, and 2pz. And the p orbital is a dumbbell shaped orbital. So let us revise our orbital shapes. The s orbital is what? The s orbital is spherical in shape. The p orbital is dumbbell in shape. So dumbbell in shape looks like number 8. That's how it looks like. So so if it is 2px, it will go along the x-axis. So it looks something like this. Ah, I'm so pained that I don't have a. Let me try to see if I have something, a feature that can help me to. Uh, there's no feature like that on this my phone. Okay. All right. So a 2px orbital is going to look like 8 along the x-axis. The x-axis is this horizontal axis. The y-axis is this vertical axis. Then the z-axis is more or less like an oblique side. So you have 2px, 2py, and 2pz. So um, atoms will feel 2px. So when we have 2p2, they will first fill 2px, then 2py. So 2pz will be left unfilled. Who gets what I'm saying? 2pz will be left unfilled. So that's why we have 1s2, 2s2, then 2p2. So that 2p2, the two electrons in the 2p2 will be in 2px and what? 2py. So that is when we now say it is divalent. Those are the ones that just thank you so much, sir. Divine. Thank you so much, sir. So that is the one that is when we now say this is a divalent um, atom. So how does it become tetravalent? It becomes tetravalent when an electron migrates from the, it is 1s2, 2s2, then 2p2. So if an electron migrates from the 2s2, right? If an electron migrates from, don't worry, tomorrow we are going to have a board. I just wanted to go live and see how many people will respond, and I think that we are very receptive tonight. So if you have a friend that you think needs to be here, so kindly share this link with them, because I'm going to be talking to as time permits us, right? So let me reduce the level of this thing so that's okay. So so if an electron goes from 2s2, if you have any question at any point in time, please make sure you ask me. If an electron goes from 2s2, it now jumps to, I told you that 2pz is empty. It now jumps to 2pz. That jumping to 2pz would now make the electronic configuration be 1s2, 2s1, then 2p3. So those 2s1 and 2p3, it now makes there to be 4 electrons that are unpaired. Before there were 2 electrons. What does pairing means? Pairing means 2. Before there were 2 electrons that were unpaired in 2p2, and those 2 electrons were in 2px and in 2py. So but now there are 4 electrons that are unpaired, and this is what a compound, this is what an atom needs for chemical bonding. So for the 2 electrons that are unpaired now, for the 4 electrons that are unpaired, this is what organic chemistry takes advantage of. It takes advantage of these electrons that are unpaired. So that's why each hydrogen atom will now attach to the electrons that are will now form bonds with the electrons of carbon that are unpaired. So that's why you can have CH4. You cannot have CH5 because the valency of carbon is not 5. Do you understand what I'm saying? That's why we can have CO2. Do you get? Because the valency of carbon can also be divalent. So moving on, organic chemistry is the study of carbon. Is the study of carbon compounds apart from oxides of carbon, apart from carbides, apart from oxides of carbon, apart from carbonates, and apart from carbides. So that is the definition for organic chemistry. So that means that when a carbon is attached to other compounds like hydrogen, that's when we now begin to talk about the study of organic chemistry. Now, let's look at the history of organic chemistry. In my UTME, I don't know if it was a UTME, but there was no particular exam I wrote. Oh yeah, I remember it was when I was writing my School of Nursing exam. There was a man called, if I still remember his name, he was the one that founded this definition for ah, I can't remember his name, but in the past, this is how they used to obtain organic compounds. Nobody, let me tell you one secret that you might never have heard from anybody. Nobody has ever created an organic compound in the laboratory before. I'm sure I'm teaching organic chemistry in a way that so many of you have not had it before. Nobody has ever created an organic compound in the laboratory before. How they get organic compound in the olden days? Olden days, I mean 1800s and the likes. How they get organic compound is directly from living organisms. That is directly from plants, directly from animals. Nobody really has ever created an organic compound in the laboratory before. So I'm trying to remember that person's name. I think is uh, I can't really remember. Maybe it starts from F. Frederick. Can't remember. Frederick something. Frederick Wöhler. Yes, Frederick Wöhler. Frederick Wöhler was the man who first created an organic. He was the one that debunked that principle when he created. Um, when he created. I'm trying to remember when he created urea in the laboratory. So by the time he created urea in the laboratory, people were now surprised. I think he's a German scientist. People were surprised that we could actually create organic compounds in the laboratory. That's when that was what started the beginning of organic chemistry. So people started realizing that we could do this. Other scientists like Kobe synthesized um, I think it's synthesized acetylene or something. You can confirm that. So these guys were the one that pioneered what we know as organic chemistry today, right? So I want to ask you a question, and I want to see how many of you know this thing, because they can ask you tomorrow in your JAMB exam, who discovered benzene? Who discovered benzene? And I'll ask you another question. So for who discovered benzene, give me the answer. Who discovered benzene? If you don't know, just say you don't know. But who discovered benzene? If you get it, I have a gift for you, and I'm very serious. But the thing now, I don't know if you guys will go and Google it because I can't see you. But who discovered benzene? Who can give a wild guess? Who discovered benzene? Who can give a wild guess to that? Out of the people that are online, is Chinyere still online? Is Esther still online? Who discovered benzene? I just want you guys to try. I just want to see what you'd say about that. So it's going. Oh, it's going. 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 All right. So it's gone. So the person that discovered benzene was Faraday, Michael Faraday. You might be very surprised that Michael Faraday discovered benzene. Yes, Michael Faraday discovered benzene. But the person that discovered the structure of benzene. Now let me ask this other question. Who discovered the structure of benzene? Oh, you don't know. You don't know the person that discovered benzene. Okay, I've said the answer to that one, so you should know that one now. But do you know the person that discovered the structure of benzene? Just mention any scientist you know, and I'll be the one to correct you. Do you know the person that discovered the structure of benzene? We're still going to talk about. Are you who discovered the structure of benzene? Mike. No, that Michael Faraday was the one that discovered benzene. Who discovered the structure of benzene? This person that is telling people to go and sleep now, or me to go and sleep now, probably you are not having exam tomorrow, or you are not even doing the exam. So let the people that are having exam tomorrow, let them benefit from this session. So I think you are the one that should go and sleep if you are tired. Alright, so the person that discovered the structure of benzene is August Kekule. August Kekule. I believe that some of us might have heard of that name before. And he told us that benzene has a resonance structure. That is, it has a double ring, it has 3 double rings and 3 single rings, right? 3 double bonds and several 3 double bonds actually in that structure, and it looks like a ring structure. So if you are drawing benzene, that's 6 carbon atoms. And who can tell me the formula for benzene? I want you to try. Who can tell me the formula for benzene? Tell me the formula for benzene. The formula for benzene is very simple. These are very likely questions that you can be asked tomorrow. The formula for benzene. So we're just going through organic chemistry from top to down, from down to top, from side to left, from left to right. C6H6. Yeah, very correct. C6H6 is the formula for benzene. So aromatic compounds, let me give you a secret. Aromatic compounds have a general formula, and the general formula for aromatic compounds is CnH2n minus 6. So for an aromatic compound, that the for an aromatic compound with 6 number of carbon atoms, that will be C6H2n. H2n means 2 times 6, right? 2 times 6 will be 12 minus 6. So that's how they got benzene to be C6H6, right? So if you are doing for naphthalene, which is like 2 benzene joined together, that will be C12H24 minus 6. 2 times 12 is 24. That will be 24 minus 6 will be 18. Do you understand? So that is the general formula for aromatic compounds. So you can confirm that. So 2 benzene joined together is naphthalene. 3 benzene joined together is anthracene. So I think you have learned something from that. So now let's go back to where we started in organic chemistry. So when the scientists discovered that we could derive organic compounds from inorganic compounds, that was when I would say the real study of organic chemistry started. So let's talk about some characteristics of carbon that makes it very fit in organic chemistry. So carbon is tetravalent. I've already told you that the carbon is tetravalent. That means one of my teachers will say carbon can be killed by 4 different arrows. That means one arrow is coming like this, one arrow is coming like this, one arrow is coming like this, and one arrow is coming like this. So it is lined by 4 different arrows. So that means in an organic compound, we are drawing the structural formula. So in organic chemistry, there are different types of formula that we'll talk about. There's molecular formula, there's general formula, there's structural formula, there is even skeletal formula, and there's condensed molecular formula. I've talked about this in one of the videos I released on organic chemistry. All right, so there is condensed structural formula. So yeah, if you are drawing the formula, structural formula for organic compounds, you are drawing that kind of thing that looks like a skeleton, where you're drawing the single bonds and all the bonds that attach to it. If you are still following, please, I want you to drop a fire emoji, or let me know that you guys are still following. All right. Okay, so for where was I? trying to remember now. I'm getting distracted. Okay, so for yes, so I was talking about the organic compound as being tetravalent. So that is what when you see a carbon atom in a compound, when you draw the structural formula, and that carbon atom doesn't appear to be surrounded by four single bonds, that carbon atom is not what is not sorry that carbon atom is not that formula is not correct. Then that means there's something wrong with it. That means there's something wrong with it. If you are the one drawing that formula, that means there's something wrong with it. It cannot be more than 4 and it cannot be less than 4. So that means if a carbon atom is already directly attached to it's already directly attached to a double bond. Take note of what I said, directly attached to a double bond. That means that it can only be attached to two more bonds, two more single bonds. If a carbon atom is already directly attached to a triple bond, that means it can only be sorry that means it can only be attached to a single bond, right? So that makes it 1, 2, 3, then 1 at this side, so that's making 4. So that's some things that you have to take note about carbon. So the other things that you have that makes carbon fit for organic chemistry is catenation property. Who wants to try a quick definition of what catenation means? What do you understand by catenation? I want you guys to be fast. Just say your mind. Just say anything you understand. What do you understand by catenation? And if you understand anything by catenation, there are some apart from carbon, there are other elements in this life or in this chemistry that catenate. If you know some of them, can you tell me some of the other ones that you know? If you don't know, just type I don't know, please, so that we move on quickly and just wrap up this session. I want it to be 1 hour. Maybe when it's 1 hour, we can end the call. Right? So tomorrow, since you guys have convinced me that this one, the me doing this is worthwhile. So tomorrow I will make it more standard and we'll look at questions that were treated in the JAMB exam today. Right? So okay, so is there anybody trying catenation who understands what we mean by catenation when we say there is a compound catenate? What does it mean when for us to say a compound catenate? What does it mean? What does it mean for a compound to catenate? Who wants to try now? Who wants to try? Who wants to help us? Who wants to help us? Okay, so for a compound to catenate, when we say a compound catenates, that means that it forms bonds with multiple of itself. So this is me. Okay, you're looking at me like this. So this is me. I can form a bond with. Let me put it like this. There's no way I can do my hand, but this is okay. I'm looking for the best way to actually put this. So let's say there's a carbon here. Carbon can form a bond with this carbon here, and with another carbon here, and with another carbon here, and you continue to progress like that. Carbon can catenate up to the extent that we can have C1000, C1000H something. No, we have C1H4, we have C2H6, we have C3H7, C3H8, something like that. That's for the alkanes. Carbon can catenate to the extent that it can give you C1000 something. So it can form several bonds with itself. And another element that catenates like that is silicon. Silicon also catenates like carbon.